Hello all, so this is the video solution to the fourth homework question on the first homework. So the first part of this question wants you to derive this formula, which basically says that the cross product is distributive. So as a note before we begin, I will represent the unit vectors in the x, y, and z direction as e1, e2, and e3 with a little hat over it to mean it's a unit vector. I believe in the solution, Morten uses XYZ, and you may also see XYZ in other places. But just so you know, either XYZ or 1, 2, 3 are all valid ways to label vectors. So I start with just writing down the definition of a cross product, and you can find this in your textbook or online. You don't need to sort of derive that one, you can just write it down. So I'm going to start with taking what's given on the left-hand side and expanding it into its components. And I'm assuming each vector has length 3. So vector A becomes this, B becomes this, and C becomes this. So for the next step, simple simplification here is just to add these two vectors. So you add B1 to C1, B2 to C2, and B3 to C3. So now I have it simplified to just a vector crossed with a vector. So now I can apply my formula from up here. So doing so gives me this sort of large formula here, which it doesn't look too nice, but we can do a few things with it. So first, I can take these A's and I can distribute them to both terms in here. Since the A's are the components of a vector, they're just a number. We know numbers are distributive. So if I do that, I get this slightly nicer looking expression. All right, and now this E1, E2, and E3 unit vectors, those are also distributive, which means I can apply it individually to each term in the parentheses here. So that means for each of these unit vectors, I could have 4 separate terms if I like. Now, I don't want to have 4 separate terms, but since I kind of want to get the B's separated from the C's, I think a good way to go about this would be to group my B's together and separate my C's. So I just went through and I highlighted the terms with B's in yellow and the terms with C's in green. So I'm just going to group those together. So I have 2 terms from E1 that involve B, 2 terms from E2 that involve B, 2 terms from E3 that involve B, and then similarly for C. Now, if you look at this yellow here, that has the exact same form as the cross product of 2 vectors. So all I have written down in this yellow line here is the cross product of A and B. Similarly, if you look at this green equation here, and you compare it to the equation for a cross product, that's also just A cross C. So if I simplify those down, I have A cross B plus A cross C, which is what I was trying to prove. So that one's not too bad. Moving on to part B. Part B basically wants you to show that the product rule also works for the cross product. So similarly, I'm going to start from this equation, assume all my vectors have length 3, and then just expand A and B. So expanding A and B and then taking the cross product of them gives me this. The derivative here, the ddt, is distributive amongst addition. That's something we don't have to prove, we can just assume it. So I can take it and I can distribute it to each of these individual terms here, and I box them in to show what goes with what. And so now I have the derivative applied to 2 terms, and I know that all of these terms are components of a vector, so all of those terms are just numbers, basically. So I can apply the product rule to that. So going from this line to this line, I just apply the product rule to each of those steps, and I've color-coded it so you can see what happens. Basically, 1 term turns into 2, so it gets pretty complicated. I now have 12 different terms across 3 unit vectors. And personally, when I was working this problem out, I kind of got stuck here. I didn't really know what to do. So when that happens, when you're trying to prove sort of from left to right something is equivalent and you get stuck, just stop and try to go from right to left. So that's what I'm going to do now. I'm just going to take where I got going from left to right and hold it. And now I'm going to work backwards. So I'm going to start with the right side of the equation, which is the dot product, the product rule already worked out. So I'm going to do a very similar thing. I'm going to expand all the vectors. So for the regular A and the regular B vector, that's pretty simple. But then for the dB dt and the dA dt, you simply write it out as the derivative of each of the components in order. And so from here, I'm just going to take the cross product in yellow and the cross product in blue, and I get this term here where the yellow corresponds to this and the blue corresponds to this, and you do that by just using this formula. And now again, I'm kind of stuck here. Like, it's simplified, but it's still messy. So here's what I'm going to do to prove they're equal. They will be equal if all of the terms in this equation also appear in this equation in the correct order and in the correct unit vector. So I went through and did the color coding for you. So for example, these two terms here in the E1 vector appear up here with the E1 hat unit vector. These two terms in green that go with the E2 vector are also right here. So if you go through and try to find all the terms, every term here is also down here in the correct spot and in the correct order. Because remember, with cross product, order is important. With dot products, we could be kind of loose on how we ordered things. So this is kind of rough proof, but these two are equal because if you expand the left side of the equation and the right side of the equation, you get to the same equation. So let me know if you have any questions on this. You can also ask Jeremy or Morten. This proof was a little bit long and a little bit harder than most things we'll ask you to do in this class, so just let us know if you need any help.